Supporting smaller conduit from larger conduit is permissible under specific conditions, offering a method to optimize structural support spacing. When considering supporting a 3/4-inch conduit from a 2-inch conduit with a support spacing of 16 feet, several key factors must be addressed. Firstly, the 2-inch conduit must be adequately supported. This means that the existing support structure for the 2-inch conduit must be robust enough to handle the combined weight of the 2-inch conduit, its contents, the 3/4-inch conduit, and its contents. If the existing supports are not sufficient, they must be reinforced or supplemented to ensure they can bear the additional load without compromising the integrity of the installation. The 2-inch conduit must be supported independently or braced to ensure it can withstand the additional weight of the 3/4-inch conduit and its contents. Independent support can involve additional hangers or supports directly attached to the building structure. Bracing can involve lateral supports that prevent the 2-inch conduit from swaying or deflecting under the added weight. These measures are crucial to prevent stress on the 2-inch conduit and its supports, which could lead to failure over time. Secondly, the 3/4-inch conduit must be securely attached to the 2-inch conduit. The method of attachment is critical to ensure that the 3/4-inch conduit remains firmly in place and does not introduce undue stress on the 2-inch conduit. Appropriate clamps are of the methods to securely attach the 3/4-inch conduit to the 2-inch conduit at the support points are necessary. These clamps should be specifically designed for this purpose and made of materials compatible with the conduit materials to prevent corrosion or other adverse reactions. The clamps should be tied into the manufacturer's specifications to ensure a secure connection without damaging the conduit. Thirdly, compliance with applicable electrical codes is essential. Electrical codes such as the National Electrical Code, Canadian Electrical Code, and International Electrical Code provide detailed requirements for conduit support and installation practices. These codes are designed to ensure the safety and reliability of electrical systems, and adherence to them is mandatory. Refer to the specific electrical code you are following for more detailed requirements. In the United States, the National Electrical Code, or NEC, is the primary standard. The NEC outlines specific requirements for conduit support, including the maximum spacing between supports for different sizes and types of conduit. It also addresses the methods of supporting conduit and the types of hardware that are permitted. In Canada, the Canadian Electrical Code, or CEC, serves a similar purpose. The CEC contains regulations specific to electrical installations in Canada, including requirements for conduit support and spacing. Installers in Canada must comply with the CEC to ensure that their work meets the required safety standards. The International Electrotechnical Commission, or IC, publishes the International Electrical Code, which is used in many countries around the world. The IEC provides a framework for electrical installations, including guidelines for conduit support and spacing. While the IEC is not legally binding in all jurisdictions, it is widely recognized as a best practice standard. In addition to these general guidelines, specific requirements may vary depending on the local jurisdiction and the type of installation. It is important to consult with local electrical inspectors and authorities to ensure that the installation complies with all applicable regulations. When installing conduit, several factors must be considered to ensure proper support and compliance with the electrical codes. Firstly, a type of conduit being used will affect the support requirements. Rigid metal conduit, or RMC, typically requires less frequent supports than electrical metallic tubing, or IMT, due to its greater strength and rigidity. Non-metallic conduit, such as PVC, may require even more frequent supports, especially in warmer climates where it can become more flexible. Secondly, the size of the conduit will also affect the support requirements. Larger conduits generally require more frequent supports than smaller conduits due to their greater weight and potential for sagging. The electrical code will specify the maximum spacing between supports for different sizes of conduit. Thirdly, the environment in which the conduit is installed can also affect the support requirements. In areas subject to vibration, such as near heavy machinery or transportation routes, additional supports may be necessary to prevent the conduit from becoming damaged or dislodged. Similarly, in areas subject to extreme temperatures, the expansion and contraction of the conduit must be taken into account when determining the support spacing. Fourthly, the method of attachment used to support the conduit must be appropriate for the type of conduit and the supporting structure. Clamps, straps, and hangers should be made of materials compatible with the conduit and the supporting structure to prevent corrosion or other adverse reactions. They should also be securely fastened to both the conduit and the supporting structure to ensure a reliable connection. To summarize, supporting a 3/4-inch conduit from a 2-inch conduit is acceptable if the 2-inch conduit is adequately supported, the 3/4-inch conduit is securely attached, and all applicable electrical codes are followed. By carefully considering these factors, installers can ensure that their conduit installations are safe, reliable, and compliant with industry standards. Remember that it is always best to consult with a qualified electrical professional to ensure that the installation meets all applicable requirements.